I want to talk about graphing polynomial functions that have repeated factors. Let me show you what I mean. I've got an example here. F of x equals 2 times x plus 1 times x minus 2 to the third power. This is a repeated factor. You can think of x minus 2 as being a factor 3 times. And the behavior of the graph near a repeated factor is going to be a little different from what we're used to. So I want to talk about that a little bit in a second. But one thing we can say right now is the end behavior is still going to work the same way it always does. For end behavior, you want to look at the leading term. And the leading term is going to be 2x times x cubed, 2x to the fourth. So if you were graphing a function like this, you would know that the two ends are going to go upward, right? Just like 2x to the fourth does. And you also know what the x-intercepts are going to be. I'll abbreviate x-intercepts. The x-intercepts are going to be -1, 0, and 2, 0. The only thing we don't really know is how the graph behaves near 2, 0. So I want to show you a little demonstration that will give you some intuition about what happens when we've got repeated factors. Okay, here we are within Geometry Sketchpad. I've got the polynomial function f of x equals x plus 2 to the 1, x minus 1 to the 1, and x minus 3 to the 1. And I can change these two exponents if I want to. Now, right now, this is a simple cubic function, right? It crosses the x-axis in 3 different places. So let me just show you. If I increase one of these exponents, you see what happens? Now that the exponent is 2, the graph touches the x-axis without crossing it, kind of hits it like a quadratic. In fact, if you show the approximating polynomial, the behavior of this fourth degree polynomial is actually quite like a quadratic near x equals -2. And if we increase it further to 3, it's going to behave like a cubic. You see that? See how it kind of approaches like a cubic? It flattens out at -2 and then starts increasing again. All right, let's take it back to 2. Now we can do this with both of these two intercepts. I'm going to take x minus 1 to the 1 and make it x minus 1 to the 2. And so now you see that I've got quadratic behavior at both -2 and at 1. Let me show you the approximating polynomial. See, here's a quadratic that approximates the behavior of my now 5th degree polynomial function, right? And I can increase this even more. So what do you